Hello everyone, thanks for joining. Today we're talking about what is machine learning. Folks are asking me to explain machine learning. They're trying to figure out how it fits in with their businesses. Our business, we're a professional services firm. We're trying to find ways to solve new problems with machine learning, but what is it? I have a couple of go-to narratives to kind of explain what it is and how it works and how management can look at making decisions with it. I'm going to try those narratives out with you today. Please reply, let me know if these narratives help. If you found a way of describing machine learning, please post it, share it with me, because I'm always trying to learn new ways of getting this great topic out and getting people excited about machine learning. So let's get started. All right, so one of the ways of describing machine learning is through a pretty big buzzword. It's a buzzword that's going to become more and more hyped in the next few years. But let's just use it because it actually, I think, is quite helpful. And that is software 1.0 versus software 2.0. Software 1.0, software 2.0. Software 2.0 is the use of machine learning to code. Casually, a lot of people have been talking about one day will computers program themselves and developers will be out of a job. I don't think they'll ever go that far. However, this concept of software 1.0, software 2.0 is kind of that topic, and it's a really good way of framing what machine learning is. So just a quick review, under software 1.0, you've got the developer spending most of their time writing code, and they write a lot of code. This is what they do day in, day out. Approximately 70% of every developer's time is programming code. So this would be the code they write, and normally there's inputs that go into it. So you have inputs, parameters, things like that. Those go into the code. Comes out of the code is the result, and I'll just say it's X, whatever X is. So for example, you could have a username and a password are the two parameters. Those go into the login code, and out comes out from that comes a token saying the person has logged into the site. So this is the very generic kind of common model for software 1.0. One of the challenges here, right, is if the parameters start to move into the hundreds or thousands, it's going to be very, very difficult for the development team to write enough logic to handle all the various conditions. And then the other thing here is that very manual process to write code in the middle. So that's software 1.0. Let's talk about software 2.0. Okay, so software 2.0. So same basic elements exist, right? You've got the code here and all the logic. You've got parameters. You've got a result. What's different is where the work is getting done. The work is getting done in the result in the parameters. You're spending all of your time working on what goes in the data. You're spending a lot of your time on the desired results. The code is not something the developers write anymore. These are pre-existing algorithms. They can be tweaked and tuned, but for the most part, that is not where the time is spent. The time is spent in the two end states. In software 1.0, the time would have been spent here, right? This is a 1.0 focus area. No more. Now you spend all of your time in the parameters and the data going in and in the result. How much time? I mean, if you were to talk to a developer in software 1.0, they would spend, on average, about 70-75% of their time programming. In 2.0, spend about 70-75% of their time on data, both the inbound data and the desired end state of that data. The programming, though, you don't do in machine learning. You can tweak it, but you don't mess with it. These are pre-existing algorithms. So machine learning is moving the effort of development from programming logic to data. And the actual time that is spent, the hours of every workday, is moving to the desired end state and the incoming data. And it's a lot of labor. Machine learning is not going to reduce your headcount in any way. In fact, it might increase your headcount. The data layer is an immense amount of work to get right. The middle area here requires a lot of very specific inbound data for it to function properly. So we'll get into more of that, but it's an interesting idea. The idea of moving the labor and the effort from the logic layer, from the code layer, and moving it to the data layer, and actually spending all your time on the data layer, the desired output layer, but not the actual code itself. That's already done for you, and that will learn and adapt and improve itself. What we got to do is get the data right. So it's an interesting kind of concept to think about. Now, one thing I want to be clear about is I don't think this is going to replace programming jobs. It's not an efficient way of solving a lot of programming challenges that developers deal with. But it does come into play when it becomes irrational for developers to write logic code around it. So if we were trying to forecast, let's say, housing prices in a particular market, I'm just going to put little slashes for types of data, for fields of data. So let's say we've got the zip code, we've got the number of rooms, we've got the square footage, we've got number of bathrooms, we've got property size. Let's say we've got samples of historical cell data. We've got local property taxes. At some point, it just keeps going, right? We have climate, we have safety of the neighborhood, police records, and those types of things. You can actually just keep going and create an immense amount of attributes that if you were trying to ask a developer to write an immense amount of logic and conditional code around, it just becomes too much. And predicting that housing price is not something that is fruitful or useful. So the determinant of when you use machine learning or when you lean into programming centers around how much data you're trying to use and how much data you're trying to pull in and create some logic around. This is why you see a lot of machine learning projects being applied to IoT, in healthcare and insurance, to finance, and to marketing, SEO, and other types of large consumer behavior data sets. So programmers, I think, are going to have jobs for the remaining several years. However, I do think all developers should learn about the alternative ways to code and the alternative ways to deliver value by leaning into machine learning. So there you have it. When I'm talking about machine learning and trying to teach new people about what it is and kind of its role, I talk about the shift of programming in code, taking in inputs, writing code, sending out outputs, and shifting the labor, shifting the effort that goes into providing that kind of value to the data, to the input, and to the result, the output, where you want it to be. And that the actual logic layer itself, the part where the thinking gets done, is done in a pre-built algorithm, a learning algorithm that you can tweak, but you don't really get into and write yourself. So the effort is moving. How much effort? Well, traditionally, programmers will say 70-75% of their day on average is spent programming. Go ask a data scientist how they spend their day. 70-75% of it is on data engineering, data quality, getting the data ready for the algorithms to do their thing and produce the desired outcome. So those are two kind of frames that I use to explain to machine learning. I would love to hear some advice on how you're articulating machine learning to others, what's working for you, what's not working for you. I want to do another video covering neural nets and explaining to fresh folks how I see neural nets and how I like to explain them to others. So stay tuned and looking forward to hearing from you.